Hello, everyone. Welcome.
Hello.
All right. Hello, all. Welcome to our Math Kangaroo live stream. We'll be waiting for a couple minutes while people roll in, but in the meantime, we have a representative from Math Kangaroo. If you would like to give an introduction.
Hi guys. Um, Today we're gonna have a live solve session with Math Kangaroo. So basically, Math Kangaroo is a non-profit organization that hosts a competition which consists of math, which is not necessarily aligned with school standards. It has very interesting problems, such as logic problems, which are related to math as well. So my name is Samar Das. I'm a ninth grader. I've been doing Math Kangaroo for around 7 years. And Math Kangaroo is one of the best experiences I've had in my math journey because I'm also a teacher assistant and help like young kids like you guys learn math, um, such as the ones which are testing Math Kangaroo. So yeah, Math Kangaroo is quite interesting, and I would highly suggest that after going through this live session today, you guys can also try participating in this competition next year as it's over this year. So I would like to introduce the co-host, the live co-host now. Thank you.
All right, thank you for that introduction. Yeah, so today we will be doing a live solve, and I am very lucky to be joined today by my wonderful co-host Haley. She really likes ducks, which are yellow, which is an interesting remark. She has not done Math Kangaroo, but it looks fun, and she likes music. So lots of very cool things from your co-host.
And I'm joined by Alina, who has also three really cool things about her. And she's actually done Math Kangaroo since second grade. So I don't know how many years it's been, but it's been a lot of years.
Lots of years, I think 9 at this point.
Oh my gosh. So maybe some of you guys can be just like her and do Math Kangaroo for a lot. And she's also really good at math. She got into MOP in 2022, which is like the highest tier of math amazingness. And she also likes the color yellow, but only on sunny days. So maybe today, maybe not today.
We can only be friends on sunny days then if you like ducks and they are yellow.
Oh no.
Luckily for you, today was pretty sunny.
Mm.
All right, I think we can get started with our problem solving. So welcome everyone. The chat is here. If you would like your messages to be displayed in chat, send them to chat relay in the Zoom. And if you're watching on YouTube, then you can just send them in YouTube. Unfortunately, they won't show up down here, but they will show up in the YouTube comments. So make sure to send to chat relay and they'll show up down here. And if your message is really, really special, then you'll get a star on your message to show how special it is. Right? Our first problem for today. In the square, you can see the digits from 1 to 9. A number is created by starting at the star, following the line, and writing down the digits along the line while passing. For example, the line shown to the right represents the number 42685. Which of the following lines represents the largest number? Okay, this is interesting. So my first thought when I see this problem is probably that if I want a really, I guess two things. One, I want to look at how long the numbers are in digits, because if I have something that's like 5 digits long, this will be long or bigger than something that's 4 digits long. And then after I find which numbers have the most digits, after this I probably want to start looking at the starting digit and comparing which one's the biggest. Okay, I see lots of suggestions already in chat. Let's see if you're correct. Okay, so A has 1, 2, 3, 4, 5 question mark? 5 digits. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do they all have 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They do. Okay. So then Sophia is suggesting that we compare the first digits, which is a good idea because they're all the same length. And there's a suggestion that E starts with 9. Okay, I think the star shows where the number starts, right? Oh, that's so true. E does start with 9 because we have a star right here in the bottom right corner, which is where the 9 is in our picture. Well, B also starts with 9. So I guess we can eliminate A, C, and D. But it's not so clear which of B and E it is. Oh, I see there's a suggestion, a very long solution. Okay. E is 98651. I believe this. 98651. And then what is B? Okay. Jade suggests that B is also 9, 8, but then it goes to 5. While E is 9, 8, but it goes to 6. So E should be bigger. I think I agree with chat. Let's see what the answer says. Indeed.
Wow, that was some nice teamwork. I really like how you guys worked backwards because you want the first digit to be starting from the back because the back is the greatest, which is 9. So that was some really great work. But now we have a different question, which is we have a cylinder. And in our cylinder, we have a measuring tape being wrapped around. And okay, so we only see the front half of the cylinder. And we want to figure out what number should be placed at this question mark over here. And, okay, so we can roughly see that the front half over here is from like 1 to 10. So maybe we can see it from like one side to the other on just one side is like a length of 10. Okay, let's say this is centimeters because we don't want that big of a cylinder. And wow, a lot of people are already getting an answer, and that's really quick. So if we say that this front part is 10 centimeters, maybe we can say then here we're starting at 20, which makes sense because 10 plus 10 is 20. And then here will be roughly around 30 centimeters. And then when we're going to wrap back around, so this will be roughly 40 centimeters. And okay, this is kind of confusing because there's the front and the back. So front here, oh, Justin says it adds 21 every line. Okay, so this is pretty useful. So front here is 10, back here to this side is 20, and then back to the front is 30, and then we're on the back again, it's 40, and on the front here, we're 50. And then around to the back here, we're roughly 60. So around here, we're going to go from 60 to roughly 70. And so I think it makes sense to say 69 because that's the only number that's between 60 and 70. And also I see a lot of people are saying each distance is 21, which means that maybe 10 wasn't the best estimate, maybe like 10.5 would have been a better estimate, but still we got within the right answer. So you guys seem to be saying 69 and I agree. So let's see if that's right. Okay, seems like we're good. That's great.
That was such an interesting approach. I didn't think of that when I first looked at this problem, but it's really smart to look at like estimation because that's so much less effort than actually thinking about how the problem works. And it's really nice that all of the answers are spaced so far apart that estimation really works. I guess if you wanted to be like more exact, then one notices that the distance from, for example, 6 to 27 is 21, and then because it's a constant distance around, then each time you should be adding 21 when you go up. Just so happens that the question mark is right over this column, so that's pretty cool. But estimation is a really good technique here. I love that. Agreed from chat. Yeah, it's so cool. Okay, folding problem. Mary had a piece of paper. She folded it exactly in half, then she folded it exactly in half again, and she got this shape. Which of the shapes P, Q, or R could have been the shape of her original piece of paper? Interesting. Okay, wait. So things I notice from the beginning is that in our desired shape, we have two lengths that are equal, then we need a right angle. Okay. Oh, people cannot see the picture. Hold on. This is a good point. Now you can't really see the text, but this is fine. Okay. People are saying E? Is this true? Okay. I can definitely see R, because if you think about R, you can take this triangle here, and then you fold it along this line. So this creates a smaller triangle like this. And then you can fold it again along this line. And then this will create a smaller triangle, I guess like this. And this looks exactly like that one. So I agree that R works. So it should be at least R. Okay. And then P looks really unruly. I don't want to do P because I'm not quite sure if I can imagine how a rectangle would fold, because the nice thing about like this square is that it's nice on all sides where it's like all of the same things. Um, well, math has a suggestion. Okay, this is interesting, but I'll come back to it. So I would like to work with Q over P because it looks a little bit nicer. And the nice thing about Q is that I can just fold it along the main diagonal, and this becomes a right triangle with two equal legs. And then this should function exactly like R did. So I know that it works. So I have Q and R. And actually, I think this means we're done. I don't think I actually have to check P because the answer choices are really interesting. In fact, already by finding R, I can eliminate A, Q, and D, or A, B, and D, because none of these have R. And then I've also validated that Q works, which means that it has to be E. And I didn't even need to check that P works for this because it's given. If I have Q and R work, then it has to be answer choice E. Now I see there were some suggestions in chat about how P works as well. In particular, I saw someone suggest that maybe we can fold it in half along this line, and then this will create a square, and then we can fold it in half along this line. which looks really, really appealing. And I think this is true in this diagram. What worried me about this a little bit was that this is a little finicky, and if our rectangle had been something like this, then this would not work. But because our diagram is so nice that it seems like the width is twice the height, this does appear to work. So I believe E is the answer. Indeed.
Nice. Well, it's always good to like look at the answer choices and like even for standardized testing, if you realize like the answer choices have like 1 and 3 work and then 2 and 3 work and then you only and then you get that like 1 and 2 work or no, and 1 and 3 work, and then there's another answer choice that's like 1, 2, and 3 work, then you know it has to be that answer choice. So it's always good to use the answer choices to your advantage.
It feels so sneaky.
Yeah, but it's
I feel like
not
I've won the
like,
game.
yeah, it's like kind of mathy because you're thinking about like what's the possibilities that are left once I've validated that these have to work.
It's like set theory. It's very cool.
Yeah. Okay, so wow, we have this very interesting. This looks like a map, which is very interesting, and it tells us that we have 3 bus stations at points A, B, and C. So a tour from A to the zoo, so this distance, and to the port, okay, and then back to A is 10 kilometers, and then a tour from B to the park to the zoo is 12, and then a tour from C to the port and to the park and back to C is 13. Okay, and finally we have like this weird kind of triangle thing. Yeah, like math says, this shape is very interesting, is 15. Okay, so we have the kind of like triangle side lengths a bit maybe. So we know like what their sums are. So maybe we can set variables. Yeah, it seems like we can set variables and then put what we want to find in terms of these variables. So maybe we have like A, B, C here, and we know A plus B plus C is 10, and then like D, E, F here, and then H, I, J. Okay, let's see if we can maybe get a bigger diagram. This is getting kind of crowded. Okay, perfect. What a coincidence. We have a bigger diagram. And now using our early variables, which I forgot the order, but hopefully that's not that important. And we want the total distance, or the shortest distance I'll take from A, wait, let's see, A to B to C and back to A. So that kind of looks like this like edge distance to me, which is A plus B plus D plus, oh my gosh, F plus J plus I. And I wonder why they give us the center, right? So we know that A plus B plus C equals 10, and D plus E plus F equals 12, and H plus I plus J equals 13. And finally, we know E plus C plus H equals 15. So it seems like what you guys are saying, which is we add these 3 equations and then subtract this equation, we're going to be left with the equation we want. So that's going to be, yeah, like Ishan says, that's going to be 35 minus 15, which is 20. And that should be one of our answer choices. Perfect. It looks like B. Yeah, like Charlie says. Wow. Let's check if we're right. Okay, yay, we're right. We're good to go.
Amazing. Okay. I believe this means we are on to our next question. 3 rectangles of the same height are positioned as shown below. The numbers within the rectangles indicate their areas in centimeters squared. If AB equals 6 centimeters, how long is CD? Okay, well, this is interesting because we have to somehow convert between side lengths, areas, and then some other side lengths. I suppose what would be nice is if we had this height right here, then if we combined these two areas and divided by the height, then we would be able to get CD, because the area of this rectangle here should be CD times the height. And I wonder if there is some way to get the height from the information we're given. Uh, oh, Roma has a suggestion. The height is 12 plus 18 over 6. Interesting. Where do you get that? Oh, I see. I see. So Roma is suggesting that we do the same exact kind of process forwards. So I was trying to work backwards and saying, okay, if we want this answer or this variable eventually, what do we do before then to get there? But Roma is suggesting that we do the same process forwards. So we find h by taking the area formed by these two rectangles together and dividing by the base should give us h, and then we can use it to get to CD. That seems like a good idea. Okay, so in this case, we will have that h is equal to 12 plus 18 over 6 is equal to 30 over 6 equals 5? I think this seems correct. Okay, so h is equal to 5. And then to find CD, we should take the area of this rectangle and divide it by 5. So in this case, we will have CD is equal to 18 plus 22, all divided by h. And then we found that h is actually equivalent to 5. So this gives us the expression, ooh, I should write where you can see it. Okay, then this will give us the expression CD is equal to 40 over 5 is equal to 8 centimeters. And I see Charlie has put in a full solution to this in chat as well. Indeed, I believe chat agrees with me that the answer is C, or 8 centimeters. Let's check. Yeah.
Nice. Okay, I feel like geometry problems are always kind of tricky, but thankfully we're not doing geometry anymore. We have this, well, this looks kind of geometric, so I don't know. Okay, so my little brother has, I didn't know I had a brother, but I guess I have a brother now. But he has a 4-digit bike lock with the digits 0 to 9, okay, on each part. And then he started on the correct combination, but of course, since he's my little brother, he's kind of not smart. So he turned each amount and now it's wrong. So now it shows the combination 6, 3, 4, 8. And oh, okay, wait, I skipped the most important part, I think, which is that he turned each part the same amount in the same direction. Okay, let's underline that because that seems important. And we want to know which of these lock combinations could not be the correct combination. Okay, so if we're turning in the same direction each time, that means we have to subtract or add a constant number to get to the correct combination. So maybe we should just go through the answer choices and see which ones work and see which ones don't work. So for A, so we have the correct, maybe starts with 8. So we have to add 2 each time and see if we get the numbers. So 6 plus 2 is 8, 3 plus 2 is 5, 4 plus 2 is 6, 8 plus 2 is 10, but since it's a circle, it cycles back. So it cycles back to 0, and that seems to work. So A is all good. Looking at B, it goes from, yeah, like Jade says, it can't be A because A works out. Checking B, we see that the first one is -3, so we have to try to minus 3 from all of them. So 6 minus 3 is 3, 3 minus 3 is 0, 4 minus 3 is 1, and 8 minus 3 is 5, so B also checks out. And then for C, it seems to be -2. 6 minus 2 is 4, 3 minus 2 is 1, so this seems to be an issue. So all of you guys who are saying C, I think you guys are right. And yeah, we got a little flash there, but yeah, the answer is C. And we don't need to check the rest. Maybe we should have, just to be safe, but it's okay.
A slightly different way to see this problem is one might consider that when you turn all of the numbers by the same amount, you'll keep the differences between pairs of numbers the same. So if the step from this one to this one is -3, then once you turn them all by the same amount, it will still be -3. So this is another way you could get to the same result. So yeah.
Wow,
But
it's really clever.
yeah, well, I suppose I feel like the turning approach might actually be slightly more intuitive just because the differences by different amounts might be a little bit difficult to keep track of, or it's easier to make an arithmetic mistake, but they do accomplish the same goal. All right, problem 21. Anne, Bob, Karina, Dan, and Ed are sitting at a round table. Anne is not next to Bob, Dan is next to Ed, and Bob is not next to Dan. Which two people are sitting next to Karina? Oh, okay. Wow. Logic. Okay. I guess I can draw my table first. I know how to do that. I can draw a round table. Then we can get to the math later. That's a table, right? Okay. Anne is not next to Bob. Dan is next to Ed. Bob is not next to Dan. Ah. Okay. I think we can start with what we know and then build off of that. In particular, the most certain thing we have is Dan is next to Ed. So let's place Dan and Ed next to each other. What is next? Okay. So of other things we have that Bob is not next to Dan. So this means this is not Bob. Maybe I will use a more intuitively not Bob color. This is not Bob. So this means that it could be A or potentially C. Does anyone have a suggestion for who could be sitting here? Or which of the two? Or should we keep going with our logic? A, because Anne and Bob are not together, so in between is Karina. Oh, that's such a good observation. Yeah, so if we have to occupy 3 chairs that are next to each other, I guess I did not draw the solds so you can see the chairs, but say there's a chair here, here, and then right here. I will also give these guys chairs. So we have a string of 3 adjacent chairs. And we know that the people who have to occupy these chairs are A, B, and C. However, we know that A and B are not sitting next to each other. So that means that this string of people has to be ACB or BCA, because this separates A and B from each other. And then we just have to choose between these two. And we know that B is not here. So this means that we should have A, C, B in that order. Oh, but we didn't even need to do all of that because we were only asked for who's sitting next to Karina, and we already figured that out because we placed D and E next to each other. That already solves the problem. We should have that A and B are sitting next to C. So, Anne and Bob. Was there a way to get to this faster? Oh, I believe just I guess all of the steps were necessary. We place E next to D. This was necessary. And then we just need to determine that. Okay. So we just need this piece of information. And then Anne is not next to Bob. We had an extraneous piece here. That's so interesting. A, yes.
Nice. Wow, logic problems are always kind of trippy, and you have to read it a few times to get it. But it's also kind of weird when they give you extra information because it always seems like they're not giving you enough. Okay, hopefully this is not a logic problem because maybe we had enough of those. Okay, but now we have some fruits, which is great because fruits are yummy. Yeah, like math says, logic is a strange thing. Okay, we have some fruits. Fruits are less strange. So we have an apple and an orange, okay? And they weigh as much as a pear and a peach. So have an apple and an orange equals a pear. Oh no, okay, I hate when they have two variables that start with the same thing. Okay, what letter do we use instead of P? Okay.
You should just draw them.
Oh, that's gonna be a lot of, okay, we'll draw, wait, no, this one's the pear. Okay, that's wrong. We need to draw a pear. No, this is the peach. We need to draw a peach. Okay, we have a peach. And, okay, then we have an apple and a pear. Oh, we need to draw the shapes now. Oh, they're not equal. Okay, it's less than, they weigh less than an orange and a peach. And together, okay, and a pear and an orange weigh less than an apple and a peach. Okay, I feel like these drawings are getting progressively worse. And also you guys can't see it, which is kind of bad. Oh no. It seems like we need some extra space. Okay. Oh no, I didn't memorize those. It's okay, we'll just work here and I'll try to move out of the way. So we need to find which pieces of fruit, or which of the pieces of fruit is the heaviest. Okay, so a lot of you guys are saying the peach already, and it is on like the greater half of our equation, like a lot more. So that's already a hint, but I don't think that's enough to tell us that it's the heaviest. So yeah, like Andy says, peach is always on the greater half. Is that enough to tell us that it's the heaviest? I feel like I need like a more solid way to justify. So I don't know. What I naturally gravitate towards is to like rearrange stuff on our equality and then add it to our inequality because it won't change the sign of the equality. So maybe you can try that. So here we can do, okay, we have apple and pear on this side. So maybe we can do apple minus pear equals peach minus orange, and then add these two. So we get, okay, even though these are different variables, they're the same thing. So pear and pear cancel out. So we have 2 apple is less than 2 peach. So we know, yeah, apple is less than peach. And then maybe we can do the same thing for this side. So we can do apple minus peach equals pear minus orange, and then add the 2. So we have 2 pear is less than 2 peach. So we know both apple and peach are, or both apple and pear are less than peach. And then looking back at this equation, oh no, this is not 2 pears less than 2 peach, it's 2 pears less than 2 apples. So we should change that. So we have pear is less than apple, which is less than peach. Yeah, and if we look at this equality here, if pear is less than apple, then we need peach to be greater than orange to compensate, to make like the 2 sides of the balance equal. So it does seem like peach is the heaviest. But this is also a long process, and it seemed kind of intuitive that peach was the heaviest. I wonder if there's a shorter way to think about this, maybe? Oh, okay. I see Sean just plugged in values that worked. Like apple equals 5. That seems like a good method to do it. Yeah. So our answer is C. And okay, hopefully that's right. And yeah, it looks like we're good.
Amazing. Okay. Problem. Oop. Oop. Problem 27. Okay. Each shelf holds a total of 64 deciliters. 1/10 of a liter? Question mark? 10 liters?
Seems,
Something?
as long as we get the liters, I think that's good enough, maybe.
Okay. Okay. Each shelf holds a total of 64 deciliters of apple juice. The bottles have 3 different sizes, large, medium, and small. How many deciliters of apple juice does a medium bottle contain? Okay. Oh, so it appears that we have a system of equations in disguise, in that we have this is equal to 64 in total, this is 64 in total, and this is 64 in total. So we can just turn them all into variables and then solve. Okay. So we have, this one gives 3 big plus, I think these are small, right? Or they're smaller than these ones, and these seem to be smaller than that. So I will assume that this is plus 4 small equals 64. And then on the next one, we have 2 big plus 2 medium plus 3 small equals 64. And then on the last one, we have, what is this? 6 small plus 4 medium equals 64. Okay, so eventually we want to isolate M because we want to find M in the problem. However, it seems to me like it's actually much quicker to isolate B first. And the reason why I think this is because if we take this equation here and we take half of it, then we will get 3s plus 2m, and that's precisely what we have here. So then it will be really, really easy to get what b is. And I'm opting for this over trying to cancel out b and s independently because I feel like that might take a little bit more algebraic manipulation. So let us try this. So we have, okay, if we have this, then we have 3s plus 2m is equal to 64. Oop, that is not how division works. 32. And then if we substitute that back in here, we should have that 2b plus 32 is equal to 64, which gives that b is equal to 16. Okay, that's pretty cool. What do we do with this? Oh, I suppose what we can do now is we have this little equation here, 3b plus 4s is equal to 64. So now we can directly find s. We have 48 coming from the 3b, which leaves 16 for the 4s, which gives us that s is equal to 4. And then finally, we can plug back into this equation here. And this gives us, okay, we have from here 6 times 4 plus 4 times m is equal to 64. And then from here we have 24 plus 4m is equal to 64, which gives us 4m is equal to 40, which should give us that m is equal to 10. Yeah!
Nice. I don't know why, but these little bottles remind me of potions. And I don't know, it seems kind of magical and cool, which is nice.
Mm.
Okay, let's see I think our last problem, although it does look like a lot. So, okay, we have 4 rectangular cards that need to be divided into 4 cells with different shapes drawn in each cell. Wow, they actually have the little drawings here. That's kind of cool. So we have a square, we have a 6-pointed star, we have a circle, and we have a triangle. Okay, and we have that cards can be placed side by side only if the same shapes appear in adjacent cells on their common side, okay? And we have 9 cards are used to form this big rectangle. And which of the following cards was definitely not used to form this rectangle? Okay. So since we're already given this initial card, I'm thinking maybe we should just try filling in what we know. Let's see if we have a bigger diagram. Okay, we do. Okay, wow. So we have this triangle. We know it has to be here because the adjacent cards have to have the same shape. And then that means we also have to have a square here, and we have to have the star here and the square here. So looking at our answer choices, we can see that C has that star and that square. And there's really nothing limiting us from having that triangle and circle here. So it seems like C is in the clear. And then do we have a triangle on the top and square on the bottom in the answer choices? Okay, it seems like we don't. So we cannot clear any answer choices using this guy. But we should also look at, okay, wait, I should change the color of what's fixed. So these 4 blue shapes are fixed, but the other ones we can change. So like for C, we can put triangle and then circle, but we could have also put circle and then triangle. But here, because we have 2 squares, we have to put another square here because it needs to be bounding the same thing. So if we have a square in the upper left-hand corner or right-hand corner, I'm not sure what it is for you guys, then we need to look at A, B, and E to see if they work. So for A, it seems like, for example, if we put a circle here, we could have, for example, if we put a triangle here, we could put a circle here. Or no, if we put a circle here, we could put a circle here. Sorry, they need to be the same. So let's get rid of that triangle. Yeah, and then we don't really have any restrictions here, so we could put the star and the triangle here, and then this would be a star, and then this would be a circle. So it seems like answer choice A is okay. Oh wait, okay, some people want to see the question again. So yeah, we're basically given these cards, which I think have 4 shapes each. And then we have, for tiling this giant like rectangle, we can only have putting cards with the same shapes next to each other. So like for this one, we can only put triangle square because it's triangle square here. Yeah, okay, back to the question. So it seems like A is okay because we can do this because there's no restrictions from the right side. So A should also be okay. And then looking at E, oh, we should look at B, right? Okay, so B, we need a triangle here, which means that a triangle is here and a circle is here. And then we also need a circle here. So a circle is here and a star is here. So it's like this. Okay, does that work? Star, star, triangle, triangle, square, square, triangle, triangle. Okay, that seems to work as well. Okay, so now let's check E, which is we have a star here. Yeah, so we're just clearing out the ones that are like not fixed because they don't have to be there. So we have a star here, which means that we need a star here. That seems like an issue because we need one of each shape in each 4-box card, right? So we can't have 2 stars. So it seems like E might be an issue. So I'm just gonna say E is the answer, but it's always good to check all of the answers. So when you guys are actually doing this, you guys should probably check the rest too. But it seems like E is not good. And you guys seem to agree that E is maybe not the right answer. So let's see. And yeah, E doesn't work.
Amazing. Wow, that was so much effort. Lots of very careful casework, which I guess is fair because it's question 30, which is the hardest problem on the test. Interesting. Did you guys have any questions about any of the problems we've done? No questions. All right, wonderful. So in that case, this will be the end of our stream for today. Thank you everyone for coming. It's been a pleasure solving Math Kangaroo with y'all. This was levels 5 and 6. And the next live solve will be June 2nd for level 5 to 6 at 8 p.m. ET. So be sure to tune in then.
Thank you guys for coming.
Bye. Thank you
Bye.
all.